Can everyone see my screen?
Yes.
Yeah. Okay. So we discussed about the different memory components of Oracle. Like we discussed about the major components like SGA and PGA, and also we have seen that in SGA there are different components like a shared pool, buffer cache, and the redo log buffer. And then other non-optional components like the Java pool and the large pool. So we'll just discuss about the shared pool in bit detail. So shared pool consists of basically two parts. One is that library cache, and the other one is that the data dictionary cache. So what happens then? Shared pool is the area where it contains all the SQLs. For example, when you write some SQL to the database, for example, select star from my tab. So what happens then? Oracle do a parse of the entire you give a select statement like a select star from table, and then result you are getting a few records. Okay. So what happens is that internally there are certain things happens. One is that the SQL is being converted and it's being checked for the syntactical error, and checks whether the user got the proper permissions, and that phase is known as the parsing. Okay. Once the parsing is completed, then the SQL get executed. That phase is known as the execution phase. And then finally, the data is retrieved from the table, and that phase is known as the fetching. So basically, you can say that any SQL execution consists of three phases. One is that parsing, and the second is that executing, and the third one is a phase fetching. So the parsing process is taking place in the shared pool. And in the parsing phase, for the first stage, what Oracle does is that Oracle is going to convert this SQL into a hash value, a numerical value. Okay. Once that is that process, and once that is completed, then it checks whether the user got any permission issues. If no permission issues, then that SQL or the parsed format or the hash SQL is being used for fetching the records. It's getting executed and used for the fetching. So you can say that the major process of this parsing is the conversion of the SQL into hash value. Okay. So once the SQL is converted into hash value, that process is being taken place on the library cache. Okay. The conversion of or the parsing stage is taking place on the library cache. Now, for the library cache to be working, Oracle has to, once it's converted into hash value, Oracle has to check whether the user got the permissions or not. So to use that activity, Oracle needs what are the permissions that user got and what are the objects he is referring. So that means that record information, that's the information about the database is being kept somewhere. So the information about the database, as I discussed, whenever the database is created, it creates a metadata. So the metadata information is being copied into the memory component that is known as the data dictionary cache. So when a parsing is taking place, it's using the library cache as well as the data dictionary cache. Am I clear here?
Yes.
Any others? Dinakar, Deepak?
Yeah, fine.
It's clear.
Yeah.
Okay. Fine. So library, the conversion, the parsing process, and the permission checking is taking place in the shared board. So once that conversion is being done, then that hashed value will be kept in the library cache for some time. Like a library cache is an area where the aging process is taking place. Like, so it will be kept in the memory for some time, and then from the memory it will be removed. Fine. So the so you can say that after some time, after a few days or few hours, all the SQLs, the parsed SQL will be aged out from the shared pool. So it's just like a conveyor belt. Something will be coming in the top, and then will be removed from there. When the new ones are coming up. So the same way, the old SQL formats will be removed from the cluster automatically.
I have a question.
Yeah, sure.
How many SQL statements will it store, and how long it will store? Any time specific?
There is no time limitation. It is purely depend upon your shared pool size.
Okay.
The shared pool size is being like you cannot individually tell that this is my library cache size and this is my data dictionary cache. That option is not there. What we are setting is that this is my shared pool size. Shared underscore pool underscore size equals 100 MB.
Okay.
So this 100 MB is divided into different. And how many hours will be kept depends upon what type of SQL you are running. Say you have run one SQL and you don't have any other activities in the database, it can be available till that is getting aged out.
Okay.
Normally, the shared pool size, once 1/3 of the shared pool is filled up, then the things will be aged out.
How many SQL statements it can store? If nobody requests for one more SQL statement after one statement, means it will be still there in the memory till it gets out. So how many requests can it accommodate?
That depends. That's what I'm telling. That depends upon the what is the request size. So for example, your SQL is one select star from table, one SQL. The second statement is writing a complex sort procedure, like some hundreds of lines. So unless we know the what is the size of this SQL and what is the each component of the shared pool divided, we will not be able to give that answer, and there is no precise answer for that. It depends upon the size of the shared pool. That's not only we can do.
Yeah, sure.
Okay, so size of the shared pool is being decided by the shared underscore pool underscore size. That's instance level parameter, and we set it by giving the command alter system set shared underscore pool underscore size equal to a value.
This is good, sir. Vimal, what happens is there are few other aspects when we are looking at the shared pool, like the cursor is the exact force similar when we are doing a hard and soft parse. So is it something that you will be later taking it up?
Yeah, that is coming a little bit stages where which we will be coming into the performance tuning activities, and so as of now we will not be covering that one. Otherwise, this will not go. Shared pool discussion itself will be keeping along.
Okay.
Okay. So library cache is the area where we are using the SQLs, and in the library cache, as I discussed, the parse format of the each and every unique SQLs will be used. So if that multiple, say for example, in the case of the packaged application, like say, for example, SAP or Oracle applications, what happens then? The shared pool area will be the each SQL will be converted into an hash value, and the second guy is also doing the same SQL statement only. So at that time, what Oracle can do is that Oracle need not do the reparsing again, because Oracle already that SQL is being converted into hash value and it's available on the memory, right? So at that time, what Oracle has to do, Oracle can use that same hash value, and then what it do that it will check whether the user got the syntactical privileges or the user got the privileges or not. Am I clear? So that way it can reduce the amount that is used for, or the amount and the CPU resource, time amount as well as the CPU resources used for that hard parsing. Fine. So at that time, when the memory or when the Oracle is utilizing the existing hash value and not going to create or generate a new hash value, or not going for the entire process of the parsing, at that time that parsing is known as a soft parsing. Okay, when Oracle is doing the everything from the scratch and go to the stage till the end of the permission checking, that activity is known as the hard parsing. And when Oracle is utilizing the hashed value which is already available in the memory, and avoid the conversion portion of the conversion of the SQLs into hash values and then check for the syntactical error, that stage is known as the soft parsing. So naturally, the more the soft parsing is taking place, naturally the performance of the system will be better, because we are avoiding the CPU utilization and the time of the hard parsing activity. Is that clear?
Yeah.
Okay. For a better performance system, it will be like we can say that it is one time parsing and multiple time executing. If your number of parsing and number of executions are same, then that means the Oracle is not at all able to utilize the previous hash values. It could be, it need not be like it's a problem with the system. It could be like that each and every SQLs are unique in your application. So unless, but that is a very rare case, that is each and every SQL becomes unique in the application. So unless each and every statements are not unique, and if you're soft parsing, if you're hard parsing and the number of executions are matching, it means that there is some issue with the configuration of your memory settings for your database. Is that clear?
So is it advisable to have a bigger cache,
Yeah,
location?
it's always to have a bigger shared pool, but it's not like that it should be going with a very huge amount. What we can do is that we can say we should be in a situation that we are not there is no shortage for the resources. At the same time, we have to make sure that we are not over allocating the resources also. So the better option is that collect the Oracle or analytics or the Oracle performance analysis periodically and find out whether everything is going in the right and the appropriate manner. For example, you have a tool called AWR, that is the Oracle workload repository, where in which you can run the workload repository during the different time, and you can find out whether your parsing and the executions are matching. If they are matching, then there is less size is there, but if your parsing is few and the executions are more, that means your system is working in the optimal way. Is that clear?
So, we normally go through AWR reports when we run some load tests or anything to see if there's any, any SQLs which we can tune. So, there are a lot of entries. It's a huge report with a lot of links and everything. So, one thing we really look at is how many DB sequential reads the database has hit. Using at that given time when you created the AWR, and we always try to keep the DB sequential reads lower, so that we don't really drive too much load to the system. Did you get the context I'm I'm asking the question from? So is it advisable to have low DB sequential reads or something like that on the system always?
It's always sequential read is always a better thing because it is reading from the index. Okay, but we need to find out by having a higher sequential read. It can be of two areas. One is that one indication that you are using your indexes properly, but another indication is that too much of the load or too much of the disk read is happening to the database. Right. Yes. So if you're like thinking that too much of disk reads are happening, then definitely there is a performance issues then. So checking only one portion of the AWR report alone is not the right way of doing a performance tuning.
True.
We need to analyze from the very basic things like whether you are having the proper hit ratios. The reason is that hit ratios indicates that whether you are allocated the memory correctly. At least it will be telling that whether you are under-allocated the memory or not.
Okay.
Okay. So then you have to find out what are the different IO activities. All the things. There are a lot of things to be checked before we coming to the conclusion that whether the scatter read or disk read is the problem.
Okay.
Okay. In this slide, it's just repeating whatever we have discussed. Like it is using the least recently used algorithm. So whenever you are, whenever the new SQL is coming, then SQL is coming on top of the on head of that list. So the least recently used SQL statements or the past SQL statement will be aged out from the list of the shared pool or list of the library cache. And it has got two structures. One is a shared SQL area, and the other one is a shared PL SQL area. So it's divided into two areas. Again, the library cache is divided into two areas, in which we have the SQL statements on one area, and we have the PL SQL statements on the other area. And as I explained earlier, the size is determined by the shared pool sizing. You don't have a control on putting this is the library cache size or this is the dictionary cache size. Now comes the dictionary cache. So the base of all the Oracle operations is the data dictionary. So why the data dictionary information is kept in the memory? The reason is that each and every SQL statement which Oracle is doing is going to check into the data dictionary, right? Because when I'm telling that select star from a tab, first question is going to check that it will be checking whether syntactically select star from tab is absolutely correct. The next question is that whether I have the privilege to access that table called a tab. So where Oracle is going to check it. Oracle has to check what are the whether it has to check so many things like whether a table called tab is created. So that information is being checked from the DB underscore tables. The second thing is that that's a DB underscore table is a data dictionary. Now the second thing is it is going to check whether the user underscore like whether I have got the privilege. That is user sys tab PRIS. When that particular table, what is the privilege this user got on this particular table? So that another data dictionary is data. Then internally some undefined or undocumented data dictionary views are again checked by Oracle. So a smooth running of the Oracle. If Oracle has to read the data dictionary from the system table space every time, definitely it is going to affect the performance of the system. So better option is that keep that data dictionary information on the memory. So whenever the data dictionary access is required, then there will be a memory-to-memory access will be or read will be taken place. That means the components on the library cache will be checking the information on the dictionary cache and check whether they are able to get the correct information. Okay, and meanwhile, there may be some, when these checks are taking place, there may be new objects added at the database side. So at that time, the data dictionary will be getting populated. So once the objects are being added or when the contents of the data dictionary is being changed, then naturally the data dictionary will get populated with the new information also. Is that clear?
Can you explain that part again?
Say, you understood what is the importance of the data dictionary?
From the beginning, if possible.
Yeah. Say, first question is like Oracle keeps information about everything, each and every component on the data dictionary. Okay. Data dictionary gets created when you create a database. While creating the database, we're using the DBC or whatever Oracle's data dictionary gets created automatically. Okay. From then onwards, Oracle is depending upon the data dictionary. All the component, all the parts of the SQL Oracle is going to depend upon the data dictionary to get the information about the objects as well as the privileges.
Okay.
Like information like how many tables are there, what's the table name, what's the table structure. Each and every minute information will be recorded on the data dictionary, and it uses the table. Now the question is, when you are giving a select star from tab, Oracle has to check a lot of things. One is that whether you got the SQL, that SQL is syntactically correct or not. So first checking. Right? Second, it's checking whether you got the permission to read that, or whether the table is there. That means it has to check minimum two things. First thing is that whether there is a table called tab is there or not. Second thing, whether you have a privilege to access from the tab. So there is bare minimum. It has to check into the two data dictionary tables. So like that, all these SQLs are running. If it is each and every SQL, if Oracle has to go and check in the system table space and verify whether a user got the privilege, it is going to take a lot of time. So better option is that keep this information on the memory, and whenever it's required, read from the memory. And that's what it is doing. So the information, once the server is starting, once the database is starting, the information about the data dictionary is kept into the area in the library, in the data dictionary cache, and at the time it will be a memory-to-memory record. That is when the components of the library cache will access the dictionary cache and get the information. Okay. And also, meanwhile, the database is up and running, there are new objects are being created, there are changes happening to the data dictionary. At that time, what happens then? Oracle will automatically populate the copy on the memory copy will be updated with the changes that take place at the other side.
Without affecting any old data.
Yeah, without affecting any older data. Okay. Even library cache dictionary calls also using the same thing. That is it is also use the if the memory. Okay, are you able to see my screen?
Yes.
Yeah. Okay, now comes the most important point or most important area which directly affecting the performance of your system. Well, that is the database buffer cache, because it is the area where the data is getting modified. So what happens is that when you are giving a select statement, say select star from employees, so whether the SQL is correct or not, whether it's irrespective whether it's going with a soft parsing or hard parsing, the parsing process is taking place on the shared board. From there, the execution phase is happening, which also takes place in the shared folder, and then the data is retrieved from the data files where the actual data is stored. From the data files, the data is retrieved back to the memory, and this is the place where the blocks are coming. Okay, from here depends upon here like this is also you having a LRU, that is a least recently used algorithm. So all the least recently used buffer caches will be aged out. That's a point here. So whenever you are selecting some data from the data files to the memory, the data blocks is coming to the top of that conveyor belt. Okay, and then whoever existing over there will be pushed back. So if you have not have sufficient memory, what happens that each and every select statement or each and every update statement will push the data which is not currently used from the memory. So what happens then? Say for example, I have given the select star from employee. Some data is already reached the buffer cache and it's sitting there. And then another guy is giving a select star from employee. Then what happens is that Oracle can utilize the data in the memory itself. Oracle don't have to go for a disk read, because reading from the disk is highly costly when compared to the reading from the memory. You can say that 1,000 times time consuming as well as the CPU consuming is that the reading from the disk when compared to reading from the memory. Okay, so naturally the performance of the system will be improved when the data is the data which the select statement or which any SQL statement is looking for, and if the data is there on the memory, definitely it will have a performance improvement. Now, how to tune this guy? Or the thing is that we have to find out the optimal size of the buffer cache, and there is no hard and fast rule for this activity. The thing is that we need to first specify the size of the buffer cache by giving the entry for the DB underscore buffer underscore cache, buffer underscore DB underscore buffer underscore size. And normally, when you are creating the database, you have to specify something called a block size, and it is available from the parameter DB underscore block underscore size. So the default or the main buffer pool will be created with the block size of your database. Am I clear here?
Which is 8K by default, right? Unless you
by default 8K.
Okay.
Yeah.
You can
yeah.
go up to
unless
32.
you specify. Yeah. Unless you specify it will be going. But there are certain times there may be certain application data which may be used a large scale. For example, like when you are selecting some data, I mean, say assume that you have a part of your application which is mainly used for the reading only. Okay, not for the updation. It's just you can say a static table, but it requires a lot of reading. So at that time, it makes sense that when you want to read it, you read a huge amount of data at a time, because anyway you are the activity the operating system activity required for the reading will be the same thing only. So when that is happening, read a huge amount of data. That's a similar logic. So at that time, you may have to create a certain tables or certain amount of data with a huge block size or a bigger block size. So at that time, Oracle is allowing you to create the non-standard table spaces. Not only Oracle, nowadays all the RDBMS vendors are allowing the non-standard block size. Okay, or non-standard table space, a table space with a non-standard block size. So it means that if you wanted to read from a non-standard table space, then there should be correspondingly a non-standard memory area available on the buffer cache also. Am I clear here? Normally, the buffer cache is equally matching with the block size of the database. But if you are going to create a table space, which is not the standard block size of your database, say I have my standard block size as 8K, but I'm going to create a table space with the say 16 kilobytes, 16 KB. It means that the data from that 16 KB table space cannot be taken into the buffer cache, the main buffer cache, because the block size is different. So what it means that if you want to create a table space of different or a non-standard block size, It means that you should be having a buffer cache which is of non-standard block size. That means you should be having an 16 KB buffer cache if you wanted to have a table space of 16 KB. Am I clear here?
So, as you said, you should be having the buffer cache of non-standard block size. Is this possible?
Yes, it's possible.
Because you give DB block size as 8 KB when creating your database. What I suppose is you can't change the DB block size once you
you cannot
change it.
Yeah, you cannot change the block size of the database. I mean, you cannot change the default block size of the database. But the table space, the individual table spaces can have non-standard block size. For that, you should be having a different block size, or you can say that you will be having, for example, you will be having a DB underscore cache underscore size is for the default cache size. Now we can have the DB to 16K underscore cache underscore size. You can say that this is the size for the 16K kilobytes buffer cache size. You can have the 32K cache size. So like that, the non-standard cache size you can specify explicitly. Is that clear?
So you mean to say that we can have two different buffer cache, one with 8K and one with 16K block size, if you're having 16K table space?
It is. You can say that it is a non-standard block size which you have to specify explicitly. If you have not,
okay.
If you have not, I'm hearing a lot of background noise. Somebody's putting into the speaker. Can they use the head? Mute it. Yeah. Thank you. So what you can see that the thing is that you have to create a non-standard block size like a DB 32K underscore cache underscore size, or DB to 16K underscore cache underscore size. That way we will be telling that this is the way to utilize. This is the buffer cache used for or reserved for non-standard block size or non-standard table spaces which you are going to create it. So they cannot utilize any other area of the buffer cache. If you are telling that 32K buffer cache is of say 100 MB, then that table space can utilize only 100 MB, not more than that.
So the non-standard data, database, whatever that cache size should be associated to a non-standard table space. He can be associated to the other table space where we have.
No, it cannot.
Okay.
It cannot be. It has to be a one-to-one mapping only. So all the standard block size will be going to the DB cache size. All the non-standard table space will be getting associated with the corresponding non-standard buffer cache.
Okay.
In case of when we are choosing the block size, for instance, we have a multiples of 4, 8, 16, 32. If I have to choose a particular block size for a particular requirement, is it very closely associated with the size, how much I am pulling the data? For instance, in a particular row, if the total row size is X amount, so I correlate it with the block size so that it becomes easier for me to have this particular block size.
Yeah, the simple logic you can think that say when Oracle is going to do a read from the disk, it is going to for at least the lowest will be one block size, right? So assume a situation where in which you have a record which is splitted on multiple block size. Say you have 2 KB block size is there, okay, but your table is row is consist of the 4 kilobyte of data. Am I clear there?
Yes.
Yeah. So that means if you wanted to have a single, say, select star from employee where ID equal to 100. Okay. So it has to retrieve from the 2 blocks to get this data. Internally 4 operating system blocks, right? So wherein which if this is of a bigger block, say for example if it's of 8 KB. Or at least 4 KB, then this read doesn't require Oracle to request for the 2 blocks. Oracle can request for only one block and it can retrieve the data. So depend upon the size of the data that you are frequently accessing. Based on that, it's say 1 or 2 exceptions on the one side, it doesn't make much difference. But if you are having huge amount of data requesting on mostly on a reading purpose, at that time you should be suitably you should understand what is your say average raw size, and then based on that you should specify your block size.
Okay, okay. And is it quite, because this is something like the developer would be having to, we have to work with the developer to understand how much is his, on an average, how much will be his table, in a table, how much row it will be, because
Yeah. Ideally, this should be discussed with the that's where the design phase of the database and the application is going to take place. Right? In the design phase, we decide that, or the application team or on the DBA database designer sits together and understand that what could be the possible raw for each. Just one second. Okay, so they have to sit together and understand what is the requirement and what is the future growth of this particular table. And normally, each and every row will not be equally utilized. So because based on that, they have to consider the different situations and make up an average row length. Based on that, you should be deciding your block size. But on the real world, what I seen till now is that it's not happening that way. Like say application team will be coming and telling us to DBA that we want to create a database, and the DBA will be creating the database with the default block size. After that, there will be definitely will be having a performance if issues will be happening. But that is the where the normally people are doing. Nobody is going to sit with the like most of the cases are not going to sit with the teams sitting together and then designs and create it. Now where it's happening on the real world.
okay.
So Vimal, for instance, I mean, if you define a block size of 32 KB, for instance, I mean, thinking, I mean, in future it's going to grow. I mean, your application will be requesting a lot of data. In that case, I mean, when you retrieve a work item, and if the data which is coming back is only 2 KB, for instance, I mean, all the time, I mean,
Yeah.
do we have to wait till it grows up to 32 KB for the?
No. Only the thing is that say you are having a block size of 32 KB. That means your block size is 32. So now the thing is that when Oracle is reading a particular record, Oracle say assume that in 32 KB is there. You have, but your average raw length is only 2K.
Mm-hmm.
Okay, that means you have 16 records are there on that particular block.
Mm-hmm.
Now, when Oracle is reading, Oracle is not going to read a particular record alone. Oracle cannot do that. Oracle has to read that entire block. So bigger the block size, if you have more amount of data, I mean what I mean to say that if you have a bigger block size, which then that rather than that is actually required, you are pulling a lot of unwanted data also.
But,
you got me?
But your SQL will kind of, I mean, when you say select star from this table where employer name equals this, then you're specifically asking for that one entry in your database, right, in your table. So how will you be looking at more data?
No, the thing is that say it has to go through that particular block, right?
Right.
Say when you're selecting, especially when this happening to kind of select statement is fine, but when it's going for a block, say where which it goes for a updation. Updation, what happens then? It is going to it needs the particular block, entire block.
Mm-hmm.
When you are going for a DML operation, when you are going for a DDL operation, what happens is that whatever the changing, the entire block is getting copied to the Aldo table space. So naturally, you are pulling more amount of data at that time.
Okay.
So the point here is that we have to be very specific on the size of the data. Otherwise, what happens is one side, the downside is that you are pulling a lot of blocks. Second thing is that you are pulling some unwanted data also.
Okay.
Fine. And say, another point to be noted is that, of course, what we discussed, the block is going for a process of least recently used algorithm, and it's undergoing a process of aging out. But there could be definitely there could be certain situations in which we may have to have a certain amount of buffer cache to be kept in the memory itself. Okay, so you don't want to go as a part of the aging out. So at that time, you can keep, you can just define a certain area like DB underscore keep underscore cache size, and this one will be kept in the memory. But at that time, you have to make sure that you are telling that certain tables are being changed to with an option cache. That means the table from that particular, the data from that particular table will be directly going to the keep cache size and will not be aged out as like it do with the normal cache size. Am I clear?
Yeah.
So you are just reserving some area, but the point here is that if you are having a reserve area of 100 MB and you have defined all the tables to be on the cache, then again you will be fighting for the memory. Am I clear?
Yep.
And then certain amount of memory that is you know very well that this table doesn't require to be kept in the memory for a long time. I mean, even if nobody is using, also this can be erased from the memory, so that next time there is no need for to struggle for the memory. So that is one of the DB underscore recycle underscore cache size. So whatever the data is coming to that memory area will be removed from the cache very quickly when compared to the buffer cache size.
Will this recycle cache size also going to clear cache on keep cache size or only cache size?
No, only say it is not going. The keep cache these three areas are not going to fight for each other.
Okay.
Okay, they are the three different areas. So if you are not specifying anything on the table level or the statement level to be cached, then it is going to normally to the DB underscore cache underscore size.
Okay.
Okay, and if you are not specifying anything on the table level or the SQL level to be going to the recycle area, again that is going to the default to the DB cache size only. But if you are specified to go to that specific area, then that will be going to that corresponding memory area.
Okay.
Okay, and from Oracle 9i onwards, we would have a parameter called the DB underscore cache underscore advice, which is going to tell you collect the statistics of the cache the database cache size and or cache usage or buffer usage, and then we will be able to predict for the current workload this should be an ideal cache size. Oracle will as of now, like Oracle is almost clear on or correct on predicting the size of the cache which we should be specified for the smooth functionality of the database by using the cache advisor. Is that clear?
Yes, there is one more which is actually which we call it as a pin. Is it coming in this?
Yeah, that's what I'm telling you, that DB underscore cache underscore size. We have to page or we have to tell that this table has to be cached, right? That cache process is known as pinning. You will be telling that alter table pin command will be used.
Okay, sir.
Yeah.
Simple. Whenever you run this command, alter system flush buffer cache, will this also clear off all the keep cache size, or it will also have the keep cache in there intact?
No, keep cache size will not be removed from the it will be still there on the command. I mean, it will be keep cache size will be still remaining the data even if you after you clear in the cache.
Okay. Okay. Thanks.
Okay. The next area is the redo underscore log underscore buffer cache. Okay. Redo underscore log underscore buffer cache is the area on the memory where which the data, or whenever you are modifying some data, the data is getting not the data actually, the changes that's required to redo this activity is or also known as the log vector, redo vector. So the redo vector is being kept on the redo into a memory area known as the redo log buffer cache, and from there whenever a user is doing a commit or rollback, or else once the redo log buffer is getting filled up, the data will be returned to the online redo log files. So this is mainly used for the recovery purpose of the transaction. So what happens is that, say you when a database is crashed, you restore from the backup and then you tell Oracle to reapply the changes. So from where Oracle will be getting the changes, will be getting the changes from the the redo log file or online redo log files or the offline redo log files. And the data to the online redo log file or offline redo log files are coming via change vector. Change vector is getting the first entry of the change vector will be the log buffer, and then from the log buffer, the log writer, the background process known as the log writer, will be writing to the online redo log files. And once the online redo log file is get filled up, depending upon whether you are having the archlog configuration or non-archlog configuration, it will be going to the archlog files by the archiver process. Is that clear?
Could you just come again?
Say when you're making a transaction, assuming like you're just giving a command like update employee set x equal to y. Okay, so Oracle needs to capture the information which will help Oracle to reapply or recover the transaction. So for the recovering, what Oracle cannot keep the entire information or entire data on the log buffer again because that information is already stored on some other place of the database. So what Oracle does is that Oracle keeps the certain very much important information to retrieve the transaction. For example, it keeps the information like on which data file, on which block, and what is the transaction that is being made. For example, block number 1, data file number 5, block number 20 has been updated with a value of 200. So that if you are updating with the value of 200, then that means it is equivalent to that you have executed the DML operation or DML operation. So now this information is known as the redo vector or the change vector. Okay. So whenever a DML operation is taking place or DDL operation is taking place, irrespective of whether that operation is committed or rolled back, whenever the transaction is changing, it updates to the log buffer. Okay. And once the log buffer is getting filled up, or when the user commits or roll back, these changes will be returned to the online redo log file with the corresponding update. If it is a commit, then it will tell you that this is committed. If it is a rollback, it will tell you that this transaction is rolled back. So when Oracle use this one for the recovery, Oracle clearly
breaking, Vimal. In between it's breaking. I'm not sure whether it's from my connection or from also from others.
Yeah, same here. Even here it's breaking.
Everyone else is breaking. Okay.
Yeah.
Is that this clear now, or still have issue?
No, it's still breaking.
Okay, fine. So what we're discussing is that, okay, so the redo log buffer is getting updated with the information of how to retrieve the transaction when the recovery is taking place. So it has the information like on a data file, on particular which block number, what was the transaction and what is the change that happened. So that way Oracle can easily recover from the failed transactions when it go for a recovery. Okay, so any kind of activities like DDL activities will be logged on to the log buffer and will be returned to the online redo log files irrespective of their status, whether it's a committed or rolled back. Is that clear?
So I know that there are redo files which gets written when you change some DML stuff, and once you fill up, the number of redo files it needs to use, it's going to push to archive logs, like it discussed yesterday. But so this redo log buffer, you kind of saying an online redo file, something like that. So anything committed goes into the redo log files. Anything uncommitted will still stay in buffer. Is that what it is?
No, irrespective of, that's what I told you, irrespective of whether it's committed or rolled back, it will be returned to the online redo log file. So whenever a change is happening, it will be first updated to the log buffer. Okay, from the once the log buffer gets either it committed or rolled back, or once the log buffer is reached 1/3 of the 1/3, in all the stages it will be returned to the online redo log file with the corresponding information like this transaction has been committed or this has been rolled back.
Okay.
Is that clear?
Yeah, okay. Yeah, it is.
So, if there is any change which has happened and it has there's a dirty buffer getting created, simultaneously a record would be getting created in the redo log file. Any change which happens would just be getting created on the redo log files.
That's correct.
Okay, and that would
So
basically be flushed out to the archiver based on a benchmark like 1/3, 1 MB or some X number of parameters based on which he could move towards the online redo log files.
Yeah.
Okay. Okay.
It moves to online redo log files, and from the online redo log files, it will be moved to the Oracle log files.
Fine, fine.
Just 1 second, guys. Okay. The next one is that large pool. Large pool is basically used for the when we are using certain specific activities, like say, for example, when you are using something called an architecture called shared server architecture, or else whenever you are using something called the certain utilities like RMAN. On specific areas only the large pool will be used. So even if you have not, say, suppose if you are using the large pool, so if you are not using the large pool, but you are still using the features like shared pool and Arman, at that time it will be utilizing that memory from the SG itself, or the remaining the part of the shared pool itself. So or a shared pool or the PGA. So depending upon that. Depending upon that, we will be depending upon what are the configuration that you are having, whether you are having the large pool or not. It is better that you will be using the large pool. Fine.
This is an optional memory setting, right?
Yeah. Right. You can just issue the command alter system set large pool and specify the memory area. And by default, the 64 MB is the size. And most of the cases, it will be that that size will be more than sufficient for us. And the important point, shared pool, like the large pool is not going to use the LRU algorithm. So there is nothing like aged out process is coming. Only the thing is that if it is not getting the sufficient memory on the shared pool area, large pool area, it's going to take from the shared pool. Simple as that one.
How will it be flushing it out? Suppose it has taken some process and it is using that process, and after the process is finished, automatically
yeah, it automatically once the process is completed. Say for example, your backup is taking place. Okay, once the backup activity is completed, it removes from there.
Okay.
So it also means that unless that activity is completing, it still holds that memory.
Okay.
Okay. So